Hi, third graders. Today we are working on lesson 20. So we're working with perimeter. And today it says I can construct rectangles with a given perimeter and find their areas. The directions say to use your square unit tiles to build as many rectangles as you can with a perimeter of 12. So it definitely would be good to have your tiles with you today. So if you have tiles, whether they are foam tiles, the colored tiles, plastic or paper cutout ones. Those would definitely be handy to have with you today. Worst case scenario, watch, but I really want you to, if you have them, to be working with them because it helps to get that math cemented in our brains so much better. Okay. So this one says use our tiles to make as many rectangles as we can with a perimeter of 12. So yesterday in our last lesson, we were working with areas. So it told us the area. So we were coming up with as many combinations as we could that would equal 12. So the area is the number of unit squares it takes to fill up the inside of a rectangle. Remember, perimeter is the distance around the outside. So we want to find rectangles with a perimeter of 12. So that doesn't mean for this lesson, we're not going to say what times what equals 12. We're going to say if we have a rectangle, we want to have side lengths that are going to add up to 12. So that means this side plus this side plus this side plus this side is going to add up to 12. So it's a little bit different today. Okay. So it does not mean that we're going to have 12 tiles that we're going to be working with because we're not concerned about the inside or the number of tiles. We're concerned about the outside adding up to 12. Okay. So if I have, let's say, let me just build a rectangle right here. Okay. Let me start with that right there. Let me just do one row of 4. So if I'm looking at the outside, so this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I'm counting, so there's 4 on the top and 4 on the bottom. So 4 plus 4 is 8, plus 1 and 1 is 2. That's not enough. That equals 10. We need to have a perimeter of 12. Okay, so build this with me. So that was not enough. Okay, so let's maybe try adding one more tile. Let's check the perimeter of this one. So do you have one row of 5? So if I'm looking at this, if I'm looking at the top, I've got 1, 2, 3, 4, 5 across the top. If the top is 5, what's the bottom? Also 5, right? So I know 5 plus 5 is 10, and then the sides are just 1 because it's 1 down, right? Does everyone see that where I'm coming up with these numbers? I'm just looking at like these, it's 1 unit across, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, because that's just 1, and 12. Did we do it? Yes, we did. So to have one of our rectangles that could have a perimeter of 12 is going to have the top and bottom are going to be 5, right? 5 and 5, and the sides are 1 and 1. So let's draw that. So it's longer and skinny, right? So we're not going to make it the same exact size, obviously. So we said the top and bottom were 5. And then we had 1 and 1. So for this one, 5 plus 5 is 10, 11, and 12. So that works there. Okay. Let's try another one. Let's use our tiles. This time, let's use, here we had side lengths of 1. So now let's do side lengths of 2. Okay. So if I do that, we'll just kind of do trial and error. If you want to pause your video and just play with it, you can definitely do that. Let's just try this. Trial and error means like you keep trying different combinations. And so trial is to try. Error is a mistake. So maybe you make a mistake, but then what do? You keep trying, right? So trial and error, we're trying it. And if we make a mistake, we just try another combination. So let's try this one. So we have side lengths of 2. So 2 plus 2 is 4. And if I look at the top, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Does this work? No. So this has a perimeter of 12 or 10, sorry. Again, if I'm going around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That has a perimeter of 10. So what could we do? We try adding another column. So this has 4 across the top, 1, 2, 3, 4, 4 across the bottom. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That works, right? Because 4 plus 4 is 8. And then we have 1, 2, 3, 4 for my side length. And 8 plus 4 is 12. We did it. So there's another combination, right? So this one has 2 rows of 4. So it's going to be a little fatter than the first one that we made. About double that size and a little bit shorter. And if we label it, it had 2 rows with 4 in each one. So again, if I'm to find the perimeter, I can do 4 plus 4 is 8, 9, 10, 11, 12. Okay. I'm going to pause your video and see if you can come up with any other combinations. So using your whatever you have for tiles. So we started out with side lengths of 1, side lengths of 2. What could we try next? If we kind of go like in a systematic order, you could try side lengths of 3 and see if that works. Okay, so I'll just get you started on that. And then just try adding columns and keep trying your perimeters and see if you can come up with 12, okay? So go ahead and pause your video and give that a go. All right, did you find anything where 3 works for a side length? So if I'm gonna try that, let me just add some more. Again, it's trial and error, so we just test it out. So even if I just do that and see what I have. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That doesn't work, right? It's not enough, so we'll try adding another one and see what we come up with. Let's try that. Okay, so let's look at our side lengths. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That works. Did you find this as well? What shape did you make here? It's a square, right? It has 3 rows, and there's 3 in each row. So all side lengths are equal, so that means it's a square. So let's draw that. So it's going to be a little bit fatter than this one, but shorter. Make sure it looks like a square. And it has all side lengths of 3. So 3, 6, 9, 12. Has 4 sides, are all the same, so 4 times 3 is 12 as well, so that works. Good. Did you find that one? Good. It's kind of fun when you get to test it out and it works, right? So we tested that one out. So we did side lengths of 1, side lengths of 2, side lengths of 3. Next one will be side lengths of 4, but we already found that, right? We already used side lengths of 4, so we wouldn't do that again. Side lengths of 5, would that work? So there's a side length of 5, okay? You want to pause your video and see if it'll work? Test it out, okay? So we already set up with 1, 2, 3, 4, 5 for your side lengths. Pause your video and see if you can do anything that would work that would give you a perimeter of 12. I just try adding one more row, or one more column actually. So I've got 5 here, plus 5 here. 5 plus 5 is 10, and then 2 and 2, so 10, 11, 12, 13, 14. Does that work? It doesn't, right? Because I'm past 12, and I want to have it a perimeter of 12. So when I add all the sides up, I don't want anything higher than 12, and I'm at 14. So we can't do anything with side lengths of 5. Okay. Is there anything more that we could do? Just try it. If you tried side lengths of 6, right? And then if we add another one there, we're still going to be too high, right? And again, you could, if you were to keep adding or going up, it doesn't make any sense because we kind of already hit our maximum amount right there, right? So I think that we have found all of our combinations that we could make that would have a perimeter of 12, okay? So if we look on at part B, it says explain your strategy defining the rectangles with a perimeter of 12. So we started with side lengths of 1, and then we just increased the side length each time, and we were seeing what we could add for how many we could add in each column until we got up to 12. Let's not write that. We can just kind of discuss it. So we started with our side lengths of 1, and then we increased the side length each time, and then we added to that column, and then we just kept checking our perimeter. We used trial and error, right? Trial and error. That means we just tested it out, and we tried to see what would work, and then if it didn't work, we tried another row or took one away, and we kind of went like that. C says to find the areas of all the rectangles in part A above. So finding the areas just means we're going to multiply the side length. So if let's say this is A, and this is B, and this is C. So for A, find the area, what do? Do I add up all these sides? That's perimeter, right? So to find the area, I'm going to multiply the side length. So remember, we can put a little multiplication sign right in the corner there. And I can do 1 times 5 equals, what's 1 times 5 equal? 5. And we're just going to say for our label, because area needs a label, so square units, since we were just using our square tiles. So the area of A is 5 square units. So why don't you go ahead and do B and C for me, okay? And then you can unpause and we'll check. Okay, so for B to find the area, did you multiply 2 times 4? So 2 times 4, what did you get for your area? 8, right? And did you remember to label it? Square units. How'd you do? Good. So this one is 8 square units. And then for C, did you multiply 3 times 3? Good. So 3 times 3, which equals 3, 6, 9 square units. Okay, so this one had an area of 5 square units, this had 8 square units, and this had 9 square units. So almost done here. D says the perimeters of all the rectangles are the same. So this one we had all of our perimeters were the same. All the perimeters were 12. What do you notice about the areas? The areas were all different. So the perimeters were the same, but the areas were different. So what do you notice about the areas? So the areas, I'm going to write it in cursive. If you want to do that with me, you can, but you don't have to. But it's good practice. The areas are all different. And that's it. So today, we worked with perimeters. Yesterday, all of our areas were the same. Today, all of our areas are different, but the perimeters were the same. And that's it for today. So it was a little bit different today in that we started with that set perimeter, and we had to try different combinations. We could try this eventually. Eventually, we'll be trying it without the tiles, where basically you'll be adding up the side lengths, right? Because we know that opposite side lengths are equal, and then we add those together. We're trying to look for different combinations that would add up to 12 or whatever that given perimeter would be. Super job today, and I'll see you tomorrow for some more math.